All right, so what I would like you to do, I would like you on your calculator to please, let me pause. We're doing 2 new transformations, three transformations today. Okay, 3 transformations. So the first thing I would like you to do is graph y equals sine x and y equals negative sine x. You need to be in radian mode, so you'll have to switch back. Remember, my algebra students are graphing. So let me show you this, just so you can just shut it off. My algebra students are graphing scatter plots. You might have dots in there. So if you have that, you go to y equals, where you're going to be entering. If you see either of these, any of these plots that are bolded and they're on, just go up. They would look like that if they're on. Just go up and hit enter on them, and that will turn them off, and then they won't interfere with your stuff. Okay, so that's the easiest way to turn those guys on and off. Okay, so anyway, please graph sine x and negative sine x. Zoom 7. Zoom 7 is your trig, so just hit Zoom 7 and it will change your window. Yeah, it's just a little smidge of a graph.
That's so special.
We can talk about that. That is section 4.7. We'll talk about those graphs. Oh, I'm gonna get that kid because I told him just a second. Yep, I told him if he didn't fix it, I was gonna hurt somebody.
What is it?
It's a starfish.
How do you do it? It was here.
Oh yeah, but I mean, you would assume.
How did they manage that? That's not.
Here. I don't remember how to take that off. I'll have to figure it out. Okay, so when you graph sine x and you graph negative sine x, what do you get? What kind of flip is that? What kind of reflection? It's an x-axis reflection. Okay, wipe that off and graph sine x and no, not sine. Sorry. Try that again. Cosine x and negative cosine x. I just want you to see what they look like. Okay.
It's gonna be the same thing.
I found it.
Oh. Wait, what's that?
If you do mess with it, you better put it back. It's in second Zoom to format. While you were dealing with starfish. Here. Okay, so this one, what do you see? What is it? It's x-axis reflection. There's a negative in front, it's an x-axis reflection, which we know that from our other work with transformations, but I want you to put it on this paper. A couple things that we want to write down about it. So, x-axis reflection. X-axis reflection happens when the A value is 0. Wow, maybe I should stop before things come out of my mouth. This is when A is negative. Okay, x-axis reflection happens when A is negative. This is why over here on A it says always read this as a positive number. So amplitude itself is never negative. Amplitude itself is never negative. If there is a negative, it just indicates that there's an x-axis reflection. So if you are going to reflect the sine of x, it's the same shape graph with the same points. It's just that instead of starting in the middle and going up, it starts at the middle and goes down. So it goes down, middle, up, middle. Cosine starts at its minimum, goes to the middle, the top, the middle, and back to the minimum. So X-axis reflection is literally x-axis reflection. Okay, so let's pause on that. That's one of our things that we need to talk about. So let's graph. Let me have you graph y equals -2 sine x. Okay, y equals -2 sine x. Not on your calculator. Okay, so what's his amplitude? 2. So that's the largest it gets, and then it gets down to -2. So the same labeling is true. The only difference is that sine starts at the middle and it's reflected over its x-axis. So it goes down, up, up, and then back down to the middle. Right? So it should look like this. Okay. Let me have you graph -0.5 cosine x. Okay, then we're going to do 2 more, and then we'll move on to our next transformation. No, 1 more after this one. We'll see. We'll see what we got. Honestly, I think that this is not tricky, but I think the hardest thing about this is making sure to remember whether you're doing sine or cosine. Because, I don't know, I personally just feel like sine is easier. It starts in the middle, which is where my brain just wants to start. What's the amplitude of this graph? 1/2. You can fraction or decimal that guy, doesn't matter. So 0.5, -0.5. And cosine's going to start at the bottom because you're reflecting them across the x-axis. So it should look like that. Okay, upside down cosine, no big deal. Now, this is where I want us to spend a hot minute. So let's say we have -3 sine x plus 2. Okay, when you start to see this on a test, so we got enough information now that this is a little bit more what it would look like on a test. There will be 4 things that we ask about because there's the potential of 4. We've got the A, B, C, and D, right? So the potential of 4 types of transformations. So when we take the test on this, you'll have the 4 questions, and then you'll have to do graph. It's not difficult. What's the amplitude? 3. No, the amplitude is never negative. So there's nowhere in this list of things where you indicate that it's negative. I just end up myself being like, for my own self, you don't have to do this, but I'll put over here on the side, there's an x-axis reflection. Otherwise, I'll forget it. Don't have to, but just don't forget it. What's the vertical shift? Up 2. Yep. What's the period of this graph? 2 pi, because that's what normal sine is a period of 2 pi. So when you graph this is why I wanted to do this one. 2 pi, 1 pi. Okay, so it's shifted up to amplitude of 3. So how high does it get? Goes up to 5. How low does it get? Now, this is the key thing here, you guys. When we talk about reflecting something that has that vertical shift in it, it's reflected around the new x-axis. So that dotted line is what it's reflected around. If you were doing this the other way, if you were doing it where you do the transformation and then you shift it up last, right? You would have the 2 pi, you would have your -3 sine x would look like that. -3, +3, and then you would shift it up 2, right? The reflection you will see the reflection along the line that you draw, along the dotted line if you're drawing it that way. So let me show you what I mean, because that was a lot of words. So sine starts at the middle, but instead of, remember that here's your new middle. So instead of going up, it goes down. So it's going to go down 3 from its midline. Okay, so the reflection happens along my dotted line. Down 3, back to the middle, up to the top, back to the middle. Looks like that. Okay, so why don't you try y equals -0.75 cosine x. That's a terrible number. We'll just go 0.5. -0.5 x cosine x -3. Okay, so I'm looking for the amplitude, the vertical shift, and the period on this guy. That is 0.5. That's a scribble out there. 0.5. So if you're graphing yours with the like you're doing the thing and then you're shifting it up, so you would do all of this part first, the -0.5, whatever, and then
I was just doing that for the example.
yeah. So you can put them all on one.
Yeah, to show how it moves from the original.
Got it. Okay, what's the amplitude? 0.5. What's the vertical shift?
Down 3.
Down 3. And what's the period? Pi. Okay. So 2 pi, 1 pi, down 3. What's the maximum this gets to? Yes. So I don't know why I made my graph so small. -2.5. What's the largest it gets to? Yeah, that would be the number I meant. Okay, it is cosine and it's reflected, so it starts at its bottom instead of the top. I should not have made him so smushy. There. It's not the most beautiful graph in the world. Questions on that?
No. Will there ever be a time where the period's not?
There's a great question. Yes. We'll talk about it today. Okay, so what I want you to do on your calculator now, so you don't have to put this on your paper. This is not going to be much of paper or anything right now. I would like you to graph sine of x and sine of -x on your calculator. Okay, so y-axis reflection, but I want you to graph it and see what happens. Okay, sine x and sine -x. So Sven said that's a y-axis reflection. Correct. Okay, so did you? You should only have these two in there.
It's like DNA.
Yeah. Now I want you to also graph y equals -sine x on the same graph.
It's the same thing.
As what?
The second one.
Yeah. Okay. So you should see that these two things are the same. Which for us, like you might be like, so who cares? Here's why you care. you will never have to graph a y-axis reflection. If you have a y-axis reflection, you'll go graph an x-axis reflection because they work out the same for sine. Okay, now get rid of all of that, and I want you to graph cosine x and cosine of negative x.
Well,
Mm-hmm. Okay, what happens?
cosine's unfazed.
Cosine is unfazed. Okay, cosine doesn't change, which is nice for you because do you know what that means? If it's there, you can ignore it. Okay, so let me show you how you can remember that because that's what's on page 3. So let's first of all do page 5. So it says y-axis reflection, that's when b is negative.
Sorry.
It's okay. Did you dent it?
No.
Oh, good. Okay, so if you get the b is negative, okay, you're going to refer to the even and odd identities on page 3. Okay, so first hour they were grumbling. They're like, that's a lot of work. Listen, I'm telling you, you don't have to remember what I just told you. I'm telling you where it's listed on your other paper. Okay, so if you look at, I'll put that back up in a second, but if you look at the even and odd identities here, it tells you that the sign of a negative number, move the negative to the outside. There's your x-axis reflection. Okay, if you have a cosine of a negative number, look what it tells you. You can ignore it. Okay, this is where it tells you what's going on. We're never graphing tangent or cotangent. We'll talk about cosecant, secant another day, which you don't even have to know that. It's these two that you need to know for if b is negative. Okay, so this tells you, hey, if this negative, this is going to be an x-axis reflection instead. If this is negative, you can ignore it. Okay, so you never will graph a y-axis reflection, ever. Because it will either turn into an x-axis reflection or it's cosine and you don't worry about it. Because it's unfazed, as Jack said. Okay, so we'll graph a couple of those later, but why would we do that? Because we're either going to graph an x-axis reflection or we're not going to graph anything. We'll combine them with some things in a minute. Now, this is the one that I need you to pay attention to. And actually, I'm going to put this up on the board. Okay. So, we have the graph. The green graph is, I didn't write it. The green graph is regular old sine. That was an unfortunate choice of colors. Okay, because this is sine. Okay, the purple graph is sine of 2x. Okay, what do you notice? Horizontal shrink. It gets compressed, right? It gets compressed in. Now, a couple things. First of all, maximum and minimum is the same. The amplitude didn't change because I didn't change the A value. This is the B value. Okay, A would be out in front, that would change the amplitude. What's the period of the purple graph? It's 1 pi. Remember that the period of the graph is how long does it take from its starting point through its whole cycle back to its starting point. The period of that is pi. Okay, now, this is kind of like, why is this number in there then? Because that's nothing to do with pi. Here's what I want you to see. How many cycles does the purple graph make in the original 2 pi? It makes 2. That's the 2. So this number actually tells you how many cycles the graph is making within the original 2 pi. Okay, watch what happens. Let me get rid of that in a second, and let me show you what happens when that's a decimal number. Okay, so that's 0.5 sign.
Making half a cycle.
It's doing half the cycle. You can see that it's doing just the top half of its cycle. That's right, it goes up and then it goes down. This guy's making one cycle or a half a cycle within the 2 pi. What's his period? 4 pi. Okay, so this is a horizontal compression, stretch, I'm sorry. So where's the same with cosine? So let's write that down a second. We're not going to take the time to graph cosine. I'll give you homework time to work on your homework when we have homework. So whoever said this was a lot, I want to remind you, you're going to get this whole page on your test. Okay, so this is a right and left stretch, and this is when you have B. I forgot what words I put on there. Oh, B, what it does is it changes the period of the graph. So when you have that number, we know that before that's horizontal stretching and compression. That's what we called it before. I like these because you can actually see it stretching out or compressing in. It's hard to see it on other graphs. This one you can tell. Now, write this down. This is important. Okay, the period, the way that you find the period is you do 2 pi divided by B. We'll explain what that means in a minute. It's not difficult. Okay. Also, we know that B is equal to 2 pi divided by the period. Eventually, we will talk about writing equations. I'll give you the information. You have to write the equation. You need that section for that. Don't worry about it now. Only going to use the first piece. And the last thing, we always interpret this as a positive number. Okay, you always interpret it as a positive number because if B is negative, you're down here on the bottom row where it says B is negative. Okay, so B is the one that can be two things. It's a reflection, potentially, not even for this, but it's a reflection and it's the horizontal change. Only we care about this is this. Okay, so here is, you guys good? Okay. Here's how this works. So let's say we are going to graph y equals sine of 4x. Well, I'll just graph this with the changed period. So I'm gonna ask you about the amplitude, the vertical shift, and the period. Okay. Tomorrow we will add in the last of them, because there's always 4 things I told you. We'll add in the last one tomorrow, but we're not worried about it today. Okay. What's the amplitude of this graph? 1, because the amplitude is the thing in front, and it's 1 because there's nothing there. What's the vertical shift?
1.
None. Right? There's no plus number on the end. There's no vertical shift, or you could put 0 if you're not inclined to write none. Now, the way that you determine the period is this formula right here. Whoops. Here you go. This formula right here. The period is 2 pi divided by B. Okay, what's B? Yep, B. So the period is 2 pi divided by 4, which we would reduce. So pi over 2, right? It's half. 2 over 4 is 1/2, but it's still the pi. Pi over 2. Okay? Now, the reason this is important, okay, and this, you guys, hopefully you're going to be like, oh, that's why she taught me that way. It's my goal. Okay? So, when you graph, what's the farthest out that goes?
2 pi.
No. 1/2 pi. We're only graphing one complete cycle. So this is going to be pi over 2. Okay? We talk about what's halfway. Pi over 4. So I want you to think about that. If you're like, I am not good at this, I'll show you how to get it mathematically, but I want you to think about a pie. Okay? Like pumpkin pie, blueberry pie, apple pie. Half, it's half of a half is a quarter, right? If you don't like that, if you're like, I don't like pie, don't talk to me about that, then eat some cake, but it's pi over 2 times a half. It's pi over 4. Now, you guys, this is why we don't number those guys, because nobody wants to think about what that is. No. Pi over 8 and something else. 3 pi over 4. No. I don't know. It's pi over 8 and 3 pi over 8. I don't need you to know that. What's the amplitude? 1. Okay, guess what? Now there's your 5 points, and you graph them like normal. There you go. So you actually do not physically see the transformation unless you realize that your whole graph, if we had graphed normal sine, they normally end at 2 pi, which would be out there. And then 1 pi would be here. And then pi over 2 is this one, and 3 pi over 2 is there. That would be your whole normal one. I'm not going to make you do that. I just want you to graph one cycle. Okay. Why don't you try for me, or let's try cosine of 3x. You got this. Okay, we're going to find amplitude, vertical shift, and period again. Okay. What's the amplitude?
1.
No question. Amplitude doesn't change because there's no A. What's the vertical shift? None or 0. Doesn't matter. Now, what's the period? Yeah, 2 pi over 3. You don't even have to reduce. Fantastic. Okay, so you're thinking, the thinking comes when you're making the graph. The more extreme thing, and that's your thinking, but. So what's the end of one complete cycle? 2 pi over 3. Okay, now, the worst part, you guys, I swear to you, the worst part is what's halfway? Which is? 1/3 pi over 3. Look, so you said 2/6, which I agree with. 2/6 is correct, but you have to reduce that. Okay? Here's another way to think about it. If this is 2 pi over 3 and you cut that in half of 2 pi is 1 pi. If you want to see the math, it's 2 pi over 3 times 1/2. Correct. Okay? So right there. 2 pi over 3 times 1/2. The 2's cancel. Okay? Don't care. Don't care. Really is what those are. Amplitude is 1. Again, hardest thing, remembering that you're graphing cosine and not sine. Yep. So let me say this, and this is just a freebie. If you're struggling to get those graphs to look really neat, think about, like when I'm thinking about them, I'm thinking about what if I kept going? Like it would have to continue and then it would get ready to go back down. So try not to think of this as the ending, even though it is. Think about it. If I was going to go through and go again, like what kind of curve would that make? For whatever that's worth. Okay, now we're going to put it all together. Okay, I think we're going to be able to do 2, and then I'll give you homework time. So let's go for sine 2x plus 1.
Now you're throwing a curveball.
Yep. What are you talking about? There's no y-axis reflection. Are there any negatives in there, son? So it's not going to be any reflection if there's not negatives. Okay? So the only time, let's say it a different way, only if you see negatives will there be any kind of a reflection. No negatives. Okay, so what's the amplitude? 4. What's the vertical shift? Okay, what's the period? 1 pi. Okay, so the way we're getting that is you do 2 pi divided by b. Well, that's pi. Okay, so you don't have to freak out on this. Okay. It's just about labeling. What's the label at the end of the graph? Pi. What's halfway? So we write as fractions, right? Because radians don't have decimals. So pi over 2 is half a pi. Okay. Once you have this done, it's just like the ones we were doing yesterday. So you have to move them up 1. There's your new x-axis. What? Yeah, it does help a lot. What's the highest this will get to? 5, because the amplitude is 4. So it's got to be 1, 2, 3, 4 above, which is 5. And the lowest it gets? -3. Once that's done, then it's the same 5-point pattern. So sometimes people are like, oh my gosh, this is so awful when it's put the 2. It's not, I promise. It's just about labeling that x-axis. So sine starts in the middle, goes to the top. There are people every year who are like, I'm not going to learn this. I'm just going to put it in my calculator. Let me say to you that if you put this in your calculator, figuring out where those points are, correctly translating them onto your paper will take longer than if you just learn how. Okay? Let alone, you're probably not going to get it right, especially when we add in the other transformation tomorrow. Okay? So this is why I just learn it this way. Okay? Last one. So let's go y equals 2 cosine negative 5x minus 1. There you go. That says negative 5x. Okay. Not 0.5. Oh, let's make him negative 0.5 for a little bit of extra fun. Oh, I know. But let's make him 0.5 because we need to practice one like this. Okay. What is his amplitude? 2. 2. Okay. What's his vertical shift? Down 1. Okay. What's the period? 4 pi. Correct. So let me show you. It's 2 pi divided by 0.5. So 2 divided by 0.5 is 4. Okay. So the period is 4 pi. Now, we have a negative. So what I was saying to Sven is there's no reflection issues unless you see a negative. So this is B. If B is negative, I have to look at the even and odd identities. What does it say about cosine? Nothing, which means we can ignore it because it's cosine. So I'll just graph a regular old cosine graph with this stuff. Okay, what's the end value on the x-axis? 4 pi. What's the middle? Those are the ones you hope you get, right? No fractions. That's fantastic. Down 1. Amplitude of 2. So what's its maximum?
1.
Yep, positive 1. What's its minimum? Okay. And it's cosine, so it starts at the top. Middle, bottom, middle, top. There you go. So here's what I would like to tell you. Not that you really care, because you are not nearly as old as I am. I've been teaching this a long time. You guys are fortunate to be in year 29 of me teaching this stuff, because I've taken a lot of years of experience and made this as easy as I can make it. Like, there are other ways to teach us that are brutal. So, brutal. hopefully you're like, this isn't that hard because it's not supposed to be. Tried really hard to make it as easy as it gets. So, it's the only flex I've got there, so let me.
At 30 years exactly.
No,
Did you sign a contract?
this one.
I sign my contract every year. My contract is yearly.
Oh. I thought it was like the NFL where you got signed like a 30-year contract.
You send a 30-year deal
So
with
for
FHS?
not using nights, then you have to make it, cause I
One-
don't.
1.2 million
And then rent, you know, rent.
My agent said, get out now.
Did you find the?
Okay, if,
Just 30 bro.
Oh, I'm not saying.
hey, if you are Gold Star Club,
Internet has public road.
no, I'm not going.
There would just be 2
Um,
chicken and 6 oxygen.
If you are Gold Star Club, you may cross off number 2, number 3, and number 5.
It doesn't look like your process.
2, 3, and 5. You may cross off. Please catch on number 1. There is a negative there. I added it. Nope.
Hey, does it do anything for cosign?
Okay.
That is not inside. It's outside. And that's an A. That's not a B. It's not a first action yet. You have your hand up, Victor. Question? No, that's okay. You do not. You do not. You will on the test, but you're fine. I don't have to apologize. You're fine when you're done anyway. So